that's the question number 16. Question number 16 said, which of the following compounds is not an isomer of 2,2-dimethylbutane? Which of the following compounds is not an isomer of 2,2-dimethylbutane? So we are talking about isomer here. We now go, before we go into solution, remember to subscribe. Your subscription is necessary for prompt message whenever we upload a video. Subscribe. It's free. Now let's go to solution. When I say that solution, we say isomers. Isomers are compounds or different compounds with the same molecular mass, which we call weight, but different structural formula, chemical and the physical property. We said isomers are those compounds, they are different compounds with the same molecular mass, which we call weight, but different structural formula, and they have also different chemical and physical properties. That's what we call isomer. But who produce them? Who produce these different compounds? What produce different compound? It have the same molecular mass. The same molecular mass, we use it to get a different compound. The same molecular mass, we use it to get different molecular compound. And those different compound has different physical and chemical properties. Then we say types of isomerism. Types of isomerism. We have structural isomerism and sterone isomerism. These are two types of isomerism. But let's go to our question. Since we have understood what isomer is, then now let's go to our question. Then what they asked me is to get, they said 2,2-dimethylbutane. They said not an isomer of, they said, which of the following compound is not an isomer of 2,2-dimethylbutane? So I'm going to look for isomers of 2,2-dimethylbutane. I'm going to look for them so that I will know which one are not its isomer here. I will now say 2,2-dimethyl. What this means, this 2,2-dimethyl means butane. That's the parent carbon. That's what 4. We have 1, 2, 3, 4. That means I have what? H3 here, and I have again H2 here, and I have here H2 again, and I have here H3. I think you're following what I'm doing. Then now, this is the parent's name, butane. Look at the butane. Look at the word butane. I've written butane. But they told me that 2,2 means the carbon carrying this methyl. The carbon carrying this methyl is at what? Carbon number 2. I will have, if I started from here or here, you can decide which side you want to start. 2,2 means the carbon 2 carrying what? Methyl. Another carbon 2 again carrying what? Methyl. And this is named 2,2-di. Why is it di? Di means that this is methyl, this is methyl. And they are in carbon number 2. They are in what? Carbon number 2. So instead of me to repeat it, I say 2,2-di means 2 methyl in the same carbon number 2. And the parent atom is what? Butane. And that's how we name this. We say 2,2. Are you see what I'm doing? 2,2-di means 2 methyl in the word 2 carbon number 2, and the parent atom is what? Butane. But let's see the isomer. Now let's see what isomer. Isomer, that's what we want to see now. Let me see the isomer. Isomers of this compound. I cannot use this compound to form this. Do you know that we can use this compound to form this? I can form this through this compound. I can form this with this compound. I can form this with this compound. This is butane. I can form this methyl. Another word, methyl. This is another compound I have formed for this, and we will call it isomer of this. And this compound have the same molecular weight. The same molecular weight. How many carbon is here? Is same what? 1, 2, 3, 4, 5, 6. 6 carbon. 6 carbon here. The same molecular weight. But different. But this compound and this compound have different chemical properties. And they have different physical properties. But they have the same molecular weight. I get what I'm saying now. So that means that's what number one. That's our definition of isomer. This is the first isomer. Second isomer I can get here. I can have this to be CH3 and the CH2. This is CH again and CH again. That's 4. And I can have this to be CH3. That's 5. I get what I'm saying now. We said 1, 2, 3, 4, 5. I can now put this man here, which is CH3. Then here will be CH2, CH2. But check it now. I have used this man to form another structural formula, which give me 1, 2, 3, 4, 5, 6. They are different. The name of this man, if I want to name this man, I will name it to be This is carbon number 1, number 2, number 3, number 4. I will name it to be 2, 3. I will put dimethyl. 1, 2, 3, 4 butane. That's the name of this one. This particular one have written. The name is 2, carbon number 2 carrying the methyl, carbon number 3 carrying the methyl, which is branch chain. Look at the branch road. So this man now is a branch road. My longest continuous road is 1, 2, 3, 4. That's my longest continuous road. This man become branch chain. This man become branch chain, which is branch road. And where that road is being fixed in carbon number 2, where this road is being fixed in carbon number 3, and what's the name of those roads that is fixed? We'll call it methyl. And then how many are they fixed? 2, which I call 2 in carbon number 2, 3 carbon number 3. There are 2 methyl being formed in butane. That's all about this. Then we'll come to this second one I have written. The name now will be If I started here to number it 1, 2, 3, 4, 5. I will not say that this is 2 methyl pentane. 2 methyl pentane. I mean 5. 1, 2, 3, 4, 5. 2 methyl pentane in carbon number 2. The third one I can draw here, I can have this to be this again, 3, CH2. I need to say this will go CH2 and CH2 and CH2 and CH3. How many are there? 1, 2, 3, 4, 5. I can take this man to this place, giving me CH taking it to this place, giving me CH3 here. Look at CH3 here. This man will remove 1 here. I have this. This is the second isomer I can get here. And the name of this one will be 3. Look at it. 1, 2, 3. Carbon number 3 carrying that branch. 4, 5. Can call it 3 methyl pentane. 3 methyl pentane. That's the name of this one I have drawn. So how many isomers have I got here? 1, 2, 3. That means that 2,2-dimethylbutane has 3 isomers. This is the only thing I can use this man to form. These only different structures I can use this man to form. And I have this one, which is 2,3-dimethylbutane, and this one 2 methyl pentane and 3 methyl pentane. and that's all about isomer of 2,2-dimethylbutane. Then now, you will now see that the structure of this man, molecular weight of this man, is same thing as molecular weight of this man, the same thing as molecular weight of this man, the same thing as molecular weight of this man, but they have different what chemical properties and physical what properties. This compound have the same molecular weight. The number of carbon are the same. The number of carbon here and this are the same, but they have different molecular weight, and that's what we call isomer of a compound. Well, let's see. Here now, in the option they give me, they said a 2-dimethylbutane. Nothing like that there. We don't have 2-dimethylbutane. We have 3-dimethylbutane. No, we have 2-3. Look at it. 2-3-dimethylbutane. We have it here. So you go to our option, you see that 2,3-dimethylbutane. That means my answer should be what? Option what? C is my answer. Number 18 said a particle that contains 9 protons, 10 neutrons, and 10 electrons is A. Neutral atom of a metal, B. Neutral atom of a non-metal, C. Negative ion, D. Positive ion. I don't know. What they ask me is that a particle that contains 9 protons, it has a 9 proton, 10 neutron, and 10 electron has what? Is what? Solution. Let's go to solution without delay so that you know what I mean. We say that a neutral atom, when atom is neutral, that they have not gone into reaction, the number of proton and the number of what? Electron are the same when that atom have not gone into what? Reaction. Are you getting what I'm saying? That means the number of proton and the number of electron is the same. So what will make the number of proton and the number of electron to be different in a what? An element or atom is that immediately he goes into reaction, there will be a difference. Either he gain electron or he lose electron. So either that element gain electron or lose electron. So you will now see that only thing that will make an element to have a different neutron and what? Proton means that that element have gone into what? Reaction. That's things. Because if he have not gone into reaction, he will have the same number of proton and what? Electron. That's a neutral atom or element. Going to the question they give me here, we see that what? 9 proton and what? 10 electron. Look at it. 9 proton and what? 10 electron. That it has 9 proton. Neutron is constant. Neutron doesn't what? Change. Then 10 electron. Means that what? This element have gone into what? Reaction. And what kind of reaction are these elements go into? That's what we want to see now. But now what I have explained to you have shown you that these elements have undergo what? Reaction. For the number of proton here is 9 and number of electron become what? 10. Meaning that the element or the atom is no more what? A neutral atom. Rather is an what? Either ion or whatever, which we are going to see now. So if I'm taking that element to be what? X. And I know that what? Atomic mass is equal to number of what? Neutron, number of neutron plus what? Proton. We have to say that in our first what? Lesson. Now atomic mass is equal to what? Number of what? Neutron plus what? Number of proton. Then now atomic mass with number of neutron now, which they give me here is 10 plus number of what? Proton, which they give me is what? 9, and that give me equals to 19. And that means that this is A, this is what? P. Are you get what I'm saying now? This implies that this element in a neutral ground, he has a what? 19 what? Atomic mass, and he has what? 9 proton. Then now, which is the same thing as what? Electron. But now, this element goes into reaction, watch me. This is 19 and this what? 9. He goes into reaction by what? Accepting what? Electron. What is the electron? He accepts electron by having this. And when he accepts the electron, he goes into this to have this to be what? 19 and this to be what? 10. Are you get what I'm saying now? This man accepted the electron. That's the reason why the number of electron differs. Why the number of proton here are 9, why this one is what? 10, and it still has the 19 as what? Atomic what? Mass. Atomic mass 19. If you check it now, it's balanced. This plus this is equals to 10. This plus this is equals to what? 19. And that means that this element gain electron, right? He gain electron to become what? Negative. When he has an electron in excess. I get what I'm saying now. When element gain electron, he will have an electron in excess. When the element lose electron, it will have what? Proton in excess. So we will now see that these elements, after going into this reaction, what he has is this. I get what I'm saying? That means it's a negative ion. So when this element gain what? Electron, he become what? Negative what? Ion. I get what I'm saying now. So that is what? Negative ion. If I go to option, I see option A, neutral atom. It's no more a neutral atom. B, neutral atom. It's no more a neutral atom. C is a what? Negative ion. Then B, positive ion. It's not a negative. It's not a positive ion because it didn't lose what? Electron. This element gain electron is a negative what? Ion. So my answer is option what? C, which is what? Negative what? Ion. Then if we now have, for instance, if I have sodium here, for example, now, and the sodium now loses electron, look at it, he loses what? Electron, which is 1 electron. This sodium will give me what is going to be what? Sodium A, which is what? Plus what? This. As he have lose electron, he's going to have what? Proton in excess. The proton will be in excess. Since this man have lose electron, the proton will be what? In excess. And what is proton? Positive. And this is what we call positive what? Ion. Positive ion. Then what of chlorine? Chlorine is non-metal. What means it gain what? Electron. Non-metal gain electron. Why metal lose electron? This man gain electron to give me what? Chlorine minus. I know what I'm saying now. And that shows that this man have good electron and he has an excess electron. Before getting the electron, the number of proton and number of electron are the same. Then excess electron now come in by getting electron. He has electron in excess, and we'll call this what? Negative ion. Have you seen the positive ion, negative ion? So for this man to have different words, atomic electron means that he gain what? Electron. Question number 19 says, what mass of water is produced when 8 grams of hydrogen react with excess oxygen? Oxygen is excess. We say, what mass of water is produced when 8 grams of hydrogen react with excess oxygen? So in other words, what they're asking us, the mass of water that will produce when what? 8 grams of what? Hydrogen is what? React with what? Excess oxygen. That means we are comparing the what? Hydrogen mass to what? The water. We are comparing hydrogen mass, which the hydrogen mass, what amount of water hydrogen mass will produce for us. Then let's go to solution before we know the what option that is correct here. No need of going to what option, rather go to solution. After solution, you go to option and get the correct answer. Then for me to solve this, I have to what? Write the what? Equation of reaction. And what's the equation of reaction? I have that what? This man, which is oxygen, reacting with what? 2H what? 2 will give me what we call 2H2O, 2H2O. That means what? Look at it, it's balanced now. 4H here, 4H, 2 oxygen, 2 oxygen. That means it's balanced. I've already balanced it straight. We say 2O plus 2H, H, and this give me that's the 2. These 2 now stand for oxygen and also stand for what? Hydrogen. Meaning that oxygen is 2 here, hydrogen is 4 here. 2 times 2 will give me 4. 1 times 2 will give me 2. Then this one, hydrogen is 4 here. 2 times 2 will give me 4. And here oxygen is what? 2 here. 2 times 1 will give me 2. That means oxygen is 2 here. Look at it. This is 1. 2 times 1 here will give me 2. Coming here, this is 1. 1 times this 2 will give me 2 oxygen. 2 times 2 will give me 4 hydrogen. Have you gotten it right? Then that means I'm repeating it again. This oxygen here is 1. 1 times this 2 will give me 2 oxygen. Are you get what I'm saying now? The same thing applicable here. This is 1 here. This is substitute to 1. This substitute to 1 times 2 will give me what? 2 oxygen. Have you got it now? I get that. Then look at this now. I cannot say that this mass of hydrogen produce this. From this reaction, I say the mass of this hydrogen produce this water. This mass of hydrogen react to this man. This man is in excess. They say this man is in what? In excess. Go to our question, they say react with excess oxygen. So we are not having a limited oxygen. Oxygen is what? Excess. Meaning that amount of this man cannot produce the water he needed. Then now I want to say for guys we said that 2H2 produces what? 2H2O. I get what I'm saying now. What is the mass? How many hydrogen is here? I know that the mass of hydrogen is what? 2. I cannot say 2 times 2 times 1. The mass of hydrogen is what? 1. Atomic number of hydrogen is 1. Then 2 times 1 times 2 will give me this. Then that will give me this man. The mass will be what? 2 times 1 times what? 2 plus this oxygen. How many are there? Oxygen is 1 here, giving me what? 2 times the mass of oxygen. Look at it. The oxygen is 2 here times the mass of oxygen, which is what? 16. Now you get what I'm saying now? And that's the atomic number of oxygen is 16. Atomic number of hydrogen is 1. That's why I said 2 times 1 times 2. I get what I'm saying now? Then the atomic number of oxygen is what? 16. And oxygen is 2 here. I said 2 times 16. Then I cannot say this times will give me 4 grams of what? H2, which is hydrogen, will give me this times this will give me what? 4. This times this will give me 32 plus 4 will give me 36 grams of what? H of what? 2H2. I get what I'm saying? 2H2O. 2H2O. That's the gram of this. Then I will now ask me, what gram? This is my reference point. Come down here. This is my reference point. This is what we call reference point. And you remember, my reference point always divide. What's my reference point? From this equation, which is my reference point, I said 4 grams of what? Hydrogen produce 36 grams of what? Water. Then what will, come over here, let's ask me now, what will the 8 grams of hydrogen will what produce? And I come down here, I will say 8 grams of the same hydrogen will produce what? Which is the question mark. What gram of what? 2H2. What is it going to produce? And you remember what I told you, that my reference point always divide. I will say what? 8 grams divided by my reference point, which is 4 grams, times 36 grams. Are you there? And this will give me equals to, this will cancel, 4 divide what? 8 will give me what? 2. That means what? 2 times what? 36. And that give me what? 72 what? Gram of what? Water. So this man, 8 grams, will produce 72 grams of water. That means it will produce what? 72 grams of water. Then I come back to my what? Option. I go back to my option. The option A said 8 grams of water, 16 grams of water, 36 grams of water, and D said 72 grams of water. When I say my answer is a what? Option what? D, which is what? That's the question number 20. Question number 20 said this compound, the compound is primary alcohol, secondary alcohol, tertiary alcohol, and glycol. So when I see the option here, I can't be able to tell which one is option until I go into solving the question. What they gave me is this, and they asked me whether the thing is the word primary alkanol or secondary alkanol or tertiary alkanol or glycol. I don't know. I will go to my word solution. Then I will recall. You recall the general molecular formula, the general structural formula of the general functional group, general what? Functional what? Group of what? Alkanal. You remember that alkanal is all about alcohol. Alkanal is all about alcohol. The general functional group of what? Alcohol. Primary alcohol. We have this, which is called aliphatic, going into what? C, and this goes here, and this goes what? Here, and this become OH. This is the what? Primary alcohol functional group. Functional group of primary alcohol is this. Look at it. Look at the primary. From this primary alcohol, we produce others. Looking at this primary what? Alcohol. Then I call this what? Primary what? Alcohol. Primary what? Alcohol. Alkanal. Primary alkanal. Then a secondary alkanal will be when this carbon sell one hydrogen here. If you sell one hydrogen here to what? Aliphatic, what we call aliphatic, straight chain hydrocarbon. If you sell this hydrogen to what? Aliphatic, which is what? Hydrocarbon. This man will turn into what? Secondary what? Alcohol. When he sell this one hydrogen, how many hydrogen does he have here? 2. This man is aliphatic. You know what I mean aliphatic? Continuous chain, which you call what? Alkane and alkyne. That's the aliphatic property family. Then when this man said this, it will have this. Look at the what is going to be. He will sell this man to have H here, and he said this to what? Maybe methyl. He said it to methyl, and this man is a what? OH. You see now the carbon carrying this OH has only one hydrogen. But in this place, the carbon carrying this OH carry how many hydrogen? 2. He has 2 hydrogen, and we'll call it primary alcohol. Then now, when he has only 1 hydrogen, we call this man secondary alcohol. Secondary alcohol. That's alkanol. I need to say alkanol, alcohol. Either you call it alkanol and what? Alcohol, or what? Alcohol. Are you going to say alkanol, alcohol? Secondary what? Alkanol, alcohol. Primary alcohol, alkanol. So this is it. Then this man now will call secondary have only 1 hydrogen remain. Do you understand? What are we considering? The carbon carrying this OH, which is alcohol functional group, which we call hydroxyl. What do we call this group? This functional group, we'll call it what? Hydroxyl. Remember, hydroxyl is a functional group of alcohol called this hydroxyl. So the carbon carrying this hydroxyl have 2 hydrogen on it. This is aliphatic, which is what? Straight chain. Then we'll call it what? Primary alcohol. When this carbon carrying OH has only 1 hydrogen on it, we'll call it secondary alcohol. When that come here, when the same carbon carrying the OH has no hydrogen on it, we will not say the word tertiary what? Alcohol. Look at it. It has no what? OH. It has no what? Hydrogen on the carbon carrying this. The carbon carrying this man has no what? Hydrogen. He has sell all the hydrogen he has to what? Aliphatic. He has said the hydrogen he has to what? Aliphatic. I will call this what? Tertiary. What do we call it? We'll call it what? Tertiary. Tertiary what? Alcohol or what? Alkanal. So tertiary alcohol is this man when he said this. Then let's go to what option they give us. They said, this man now, looking at this man now, look at the carbon carrying OH. Look at the OH here. The carbon carrying that OH. Look at the carbon carrying the OH. How many hydrogen does he has? He has one hydrogen. So I cannot call this man secondary alcohol. I think you have seen it now. You now can call this man what secondary alcohol because he has only one what hydrogen attached to the what carbon carrying OH. So I will call it what secondary alcohol. I will look at my option here. You see B is secondary what alkanol. So my answer is option what B is my answer. Question number 21 says general formula for alkanones is this. This option they give us. General formula for alkanones is this or this or this or this. Solution. We go straight to solution. I say solution. General or functional group. General or functional group, or what we call formula of ketones or alkanones. This is either ketones, we call it ketones, or alkanones. We said the functional group of what? Ketones or alkanones. You look at this functional group. Which is this stand for what? Aliphatic. Why this man stand for what? Aliphatic. That means aliphatic here. That means a straight chain here. And this man carrying the functional group, which is the functional group being in between. That means is in between. Note it. This man carrying the functional group is in between what? Aliphatic and what? Aliphatic, which is called straight chain is aliphatic. Then now, or we have this, which is this man mean what? Aromatic, which is what? Benzene. We have got rings. Either benzene or rings are here. Why this one is what? Aliphatic. But this man always being in between of these two. Then, for example, I give an example. I say an example that we have. Look at this. And look at him here. Look at aliphatic. Look at aliphatic. Look at aliphatic. Look at aliphatic. Look at the functional group and in between. Then we say that what? I have to number this carbon carrying the functional group. I have to number this for naming. I want to name it. I have to number such that the carbon carrying the functional group will have the least number. And what's the functional group? Look at the carbon carrying the functional group here. So I have to number this. If I want to name it, I have to number it such that carbon carrying the functional group will have the least number. So if I number it like this, 1, 2, 3, 4, you see that this carbon number 2 carrying the functional group. But if I number it like this, it will be 1, 2, 3. You see that carbon carrying the functional group will number 3 carbon. Why numbering this way? To be number 2 carbon. So number 2 carbon is the least number than what? 3 carbon. So to number it, I will number it this way, which give me this one 1, give me this one 2, and give me this one 3, and this one what 4. And the carbon carrying the functional group now is 2. I will now say 2, which is carbon carrying the functional group. Butanol means that what? I'm talking about 2 butanol means what? The functional group and the carbon number 2. And what's the parent name? Butanol. How many? Count it 1, 2, 3, 4. That's my straight chain, which is 1, 2, 3, 4, 4 carbon. That means what? Butanol. No. We are talking about no. This functional give me that what is the no. Then I come to this, the same thing here. I give another example again. I will look at this. You see the aliphatic, which we call one of the aliphatic. Example of aliphatic here is what? Methyl, which is aliphatic. Then I cannot name it by saying no, drawing the word. Either I call it 1, 2, 3. I will call it what? Propanol, or I will call it what? I can call it proper 1, proper 2 on, propan 2 on. What am I saying? I'm just telling you where the carbon what carrying the functional group is, which is carbon number 2. Look at it 1, and here is what 2, and here is what 3. So I can call this what propan 2 on, or we call it propanol. Then now I come to this another example I gave you here. I come to another example I gave you here, and you look at this, look at the aliphatic here, look at this man in between, look at another aliphatic. Then I have to check my straight chain, my longest straight chain. If I take my longest straight chain, which you call longest continuous straight chain, I'll say 1, 2, 3, 4, 5. That's my longest continuous chain, which the one carbon carrying the functional group must be among. I have taken it to be what? 5. So this might become what? Attachment, which is what? Branch road. This is my longest road, while this might become the branch road. Then how am I going to number this? Because if I want to name this, I have to number it. How am I going to number it? I will number it so that what? Carbon carrying the functional group. In this case now, it's no more carbon carrying the branch chain. The carbon carrying the functional group is the one I'm going to consider, not the one carrying the branch chain. Look at my branch chain here. But the one I'm going to consider in this case is the carbon carrying the functional group. I have to number it so that that carbon will have the least number. Therefore, I'm going to number it this way, which will give me here 1, here 2, and here 3, and here 4, and here 5. If I number it this way, you will see that this one will be 1, 2, 3, 4. And the carbon carrying this man will be at 4, carbon number 4. But as I number it this way, you see that carbon carrying this functional group is carbon number 2, which is the least number. So for me to number it such that it will have a least number, I have to number it this way. For me to number it so that it will have a least number, I have to number it this way, not this way. And my branch chain is at what? Carbon number 4. If I number it this way, my branch road is not carbon number 4. I will say what? 4 hyphen, what is it? Methyl. 4 methyl 2. What am I saying? 2. This 2 means what? Where the functional group is 2 pentanol. 2 what? Pentanol. I can also write this way. 4 methyl pentatone. What am I saying? 4 methyl pentatone. It's the same. Are you get what I'm saying? This is telling me where the functional group is positioned and carbon number 2. This man is telling me that what the branch chain, which is in methyl, is at carbon number 4, while the functional group is at carbon number 2. And the parent name is what? Pentanol. Then pentanol. So that's it. Let us look at other example. From this, we can answer the question. The question says, what is the general what's the general formula for what? Alkanone. And I can see that option A is off, option B is the correct one. Look at it. Aliphatic. Give me 2 aliphatic, which is 2 aliphatic and CO. This CO stands for this. Therefore, I can now say my answer is option what? Option what? B is my answer. This is aldehydes, and which we call alkanal. Aldehydes is also known as alkanal. General formula, or what we call functional group, is aliphatic with carbon carrying O, but you see that H is the atrium end. Or aromatic, carbon carrying the functional group with what? H at extreme end. You see the difference between this man and the what? Alkanone. Alkanone has the aliphatic here and aliphatic here, so that you will not be confused over this. Alkanone have aliphatic here and aliphatic here, and this man at the middle. So that's it. And this functional group can be written this way, so that you always remember it can be written this way, you see. And when you write it this way, it will look like what? Alcohol. It's not alcohol. How you will know whether it's alcohol is that immediately you write this, you see the aliphatic, this man, and you see that alcohol is always like this, which is one bond. But this one now, you see that when you put one bond, is this carbon saturated? No, it's not complete. The bond is not complete. Therefore, you will not see that this man is not alcohol, rather is a what? This O and what? This making the bond to be complete. You see it 1, 2, 3, 4. But when you now assume it to be what? Alcohol by putting this, you see that the bond will not be complete. See, this man is lacking 2 bonds. Therefore, you will not see that this man now is going to be what? This, not this. Until you get me right. You see that, so that you will not be confusing yourself with this and what? Alcohol. You have seen how you can identify it, whether it's alcohol or not. So now, going to the example I gave you here, we give you one example by saying that what? Look at it. And you see the carbon carrying this functional group at the extreme end and what? H at the extreme end. And I have to number this so that I want to name it. If I want to name this, I have to number it so that carbon carrying the functional group will be what? The least number. And that carbon carrying the functional group is 6. I begin to count it 1, 2, 3, 4. And when I have counted it, this is my longest continuous chain. Why this man become my branch chain? Then my branch chain is in carbon number 2. That's the branch road is carbon number 2. As I number it 1, 2, 3, 4. I can't number it this way because I told you that you will number it such that what carbon carrying the functional group will have the least number. Then when I said here, I will now have my branch chain is what? Number 2. And which is my branch chain? Who is that person? Methyl. And what is my parent name? We call it 4, which we call boot, stand for 4. And what is the parent name? We said what? Na. We say now butana. We now said 2-methyl-butana. That's the name of this one. I come to this one. You see that this one, the functional group is 6. I can count it 1, 2. I can now say what? Ether now. Ethers. We are talking about ethers now. General formula or functional group is what? Aliphatic here. O at the middle. Another aliphatic. That's for ether. And when you look at this aliphatic, I put hyphen here. What this hyphen signify? This particular side is for parent name. This particular side, the aliphatic that will be here will be for my parent name. Why this one will be what? Initial name. Looking at it, I said this one will be for parent name and this one will be initial name. Let us look at the example. Example this. I have this. You see aliphatic here, you see aliphatic here. This one stands for parent name. And I will now say that the first one, look at the one I will mention. I will call it what? Look at IUPAC name. The IUPAC name become what? Methoxyl. Look at what I mentioned, methoxyl. Methyl is here, I'll call it methoxyl. Look at the oxyl. Then look at the parent name, which is what? Methane. I'm coming again. This one become what? Methyl-oxyl. Methoxyl. Then I call what? This one what? Methane. That's the what? IUPAC name. But common name of this man have also common name. Common name will be what? Dimethyl ether. Look at it. We'll look at the common name here. We say dimethyl what? Ether. Why is it di? I put di because I have 2 methyl. Look at methyl here. Come over here. You see methyl here, methyl here. Then I will not say what? Dimethyl what? Who am I talking about? Ether. Which is it? That's my common name. Then I can now come to another example, which is this one. This man can be written this way, you know. Another way I can write this is what structure and this is what condensed form. This man is something as this. That's why I just write it so you to know this is another way we can write it without putting the word, the bond for you. Write it this way. Then another example is this. You'll see that what this is aliphatic here. Look at what another aliphatic and look at the word O at the middle. So we are not always to be putting the hyphen, putting the bond for you. Write it in a condensed form this way, but you will still split it by yourself. Then when I see this is aliphatic here, look at another aliphatic here, and look at O in between. Then I say this become my parent name, and this one become my initial name. Then this is my initial name, which is what? Met. I will call it what? Methoxyl. Then how many carbon is here? 1, 2, which is what? Ethane. I will now say methoxyl ethane. Look at it. Methoxyl what? Ethane. Methoxyl. How many carbon? 1, 2, methane, which is my parent name. Then the common name for this will be what? The first person is what? I will mention it that before E, I will get what? Before M, I will first get E before M. I will now check it. This is this is methyl, this is what? Ethyl. This is methyl, this is ethyl. Then I will first of all mention ethyl, which is after E before I count what? M. I do it at what? Alphabetical order. This one is what? Ethyl, this one is what? Methyl. So I will say ethyl methyl ether. Ethyl methyl ether. Ethyl methyl ether. Why did I start with what? Ethyl. E. If I count A, I will have B, I will have C, and I will have what? D, and I will have E, I will have F, and what? G, H, and what? I, J, K, L, M. Have you said it now? So I'll first meet E before I meet M. So I'll first pronounce what? The E, which is what? Ethyl. Then I'll pronounce the second one, which follows with the word methyl, and I'll say what? Ether. These zeros stand for what? Ether. That's what you say. What? Come over here, you see. Ethyl methyl what? Ether. Ethyl methyl what? Ether. That's the common name. Then another example, I have this again. You see the one will give you hyphen here. This is what aliphatic. Look at the O at the middle. Look at another aliphatic. And this is my parent name, if you can remember. I said this one is my parent name. This one my initial. I would then say this one is what? Only one carbon, which is what? Methyl. I will say what? Methyl oxyl. Methyl oxyl. How many are here? 3. Okay, what? Propane. Methoxyl propane. You now see it here. Methoxyl propane. That's the IUPAC name. You see the IUPAC name. Then I will not come to common name. I will say what? Methyl propyl ether. Methyl propyl ether. You see that I will first of all mention M before what? P. That's why I will say methyl propyl what? Ether. Here is what? Methyl. Here, become how many carbon? 1, 2, 3, which is propyl. This one is what? Methyl. This one propyl. I first count M before P. Therefore, I said methyl propyl what? Ether.